Hey, what's up guys? I'm Dave Boyer, aka Mr. Boyer, aka the Swamp Man. I'm here at Sand Harbor Beach in Lake Tahoe, in the state of Nevada, and want to talk to you quickly about density. So we'll study quite a bit about density. We'll be comparing density of different objects. One of the ways that we use density is to figure out whether or not something might float or not. And that's what I wanted to show you here at Lake Tahoe. So, got a couple of items. I'll start with a piece of a pool noodle. You probably know the pool noodle is going to float, right? Yeah, it floats easily. So why does a pool noodle float? It has to do with density. The liquid that it's floating in is water. Water has a density of 1.0 grams per cubic centimeter. It's like what we use as a basis for comparing densities of all objects. So if we have an object that has a density of greater than 1.0 grams per cubic centimeter, then that object's going to sink in water. If the density is less than 1.0 grams per cubic centimeter, the object's going to float in the water. So one of the misconceptions is that objects, whether or not they would float or not, has to do with how heavy they are. So I wanted to compare two objects I picked up off the shore. I've got a pretty large pine cone here. It's really heavy, and a small little rock. You probably know rocks are going to sink, but it's kind of counterintuitive to think that the rock would sink and the pine cone might float when the pine cone is so much heavier, but it's because of the density. So I'm going to put the pine cone in the water first and let you see it. So as you can see, the pine cone floats in the water, which means that this pine cone has a density of less than 1.0 grams per cubic centimeter. Compare that to our rock, much smaller, much less mass, but rocks have a density, almost all rocks have a density greater than 1.0 grams per cubic centimeter. We'll probably look at some rocks in third quarter and see like pumice. Pumice is a really light, a really low density rock that actually does float in water. But you won't be able to see this too much because it's going to drop to the bottom pretty quick, but I'll show you the rock hitting the water. So the rock sinks down to the bottom because its density is greater than that of the water. If something were to have a density of the exact same as water, 1.0 grams per cubic centimeter, then it would kind of be suspended in the water, and you could move it up and it would stay there. You could move it down and it would stay there. It wouldn't move up or down on its own like the pine cone would. If you push the pine cone all the way down to the bottom, it rises back up to the top because its density is less than that of water. But if the pine cone had the same density as water and you put it down at the bottom, it would stay down at the bottom. Pretty cool stuff. Gonna get back to where my family's playing along the shore here. It's a nice beach, nice day. Although we've had a lot of smoke here in the Sierras in the last few days. But I just wanted to stop and share that with you and tell you that science rocks. Peace.